Welcome to the lesson 37 of industrial instrumentations. In this lesson, we will study the pollution measurements. When we are talking of the pollution, basically we are talking of the environmental pollutions or the air pollutions or the type of gases, that means the carbon monoxide, nitrogen oxide, all these type of gases, how it is making the air polluted, and we must measure it, because you know the certain, I mean, if it crosses some limit, that is and it's not safe, it is hazardous for the human being. Pollution will be there. You cannot, in industrializations, you know, there will be pollutions. You cannot avoid pollutions. You have to live with pollutions. But what is the level, we must know, because if you stay in some forest, or that's obviously the pollution will be less. But if you live in a city, obviously there will be some pollutions because of the exhaust of the car and truck and all these things, burning of the fuels, burning of the waste, because you know the waste is a big problem in cities or metropolis. They cannot dump it, and usually they burn it, because that will reduce the volume of the waste. So that will cause the pollutions. The factories, the power stations, all these things will make the air polluted. Now we must know what is the concentrations of the different gases, and if it is within the safe limit, fine. Otherwise, you have to check it, and you have to warn. Our goal is to warn the public or the so that they will also know that what type of pollution they are going through, and what is the what should the safe level of content. Now in some countries you will find that the forest fire, that also will cause the pollutions. Okay. Some countries where there is a where it like Australia, when it is very dry weather, so there is a pollutions, like means when the wind blows, obviously it will pollute. Now you see some of the pollutions, some of the exhaust of the gases, like you can one can see either by its nature, or by it basic color, when it's dark in color, but some are so small that you cannot it's very difficult to see in the without any microscope. So these are the all different type of pollutions. We are not considering the pollutions of the river on this particular measurements. Lessons we will consider only the pollutions in the air, right? So let us look at the contents. Pollution measurement, introduction. The contents are introduction. Then we have a sample collection, because sample is most important, because you know we will collect the sample from air. Excuse me, and will what is the type of container that should be, and what type of how long will you store it. So those are very important for this type of measurements. Then the detection of carbon monoxide, because carbon monoxide is one of the extremely poisonous gas, so that it contains its presence in the air always is harmful for the public, or for the human, or for any animal being. So its concentration should be below some limit, so that we must determine. Then we have detection of the nitrogen oxide and nitrogen dioxide, which is called a Nox Analyzer. Nox Analyzer is not only common in the streets. We are also in the environments, also in the many industries also they measure this one, because to have a safe good environment for the workers or the people, those who are working in the industry or the plant. Detection of sulphur dioxide, this is another pollutions, we must measure it. Then detection of ozone, detection of hydrocarbons. Okay, this hydrocarbons also is a like methane. Okay, these are very it's not good for the human being. So this contains also, you must know the concentrations of the methanes also. And air quality index. The air quality index means visibility. Then what is the PM10 concentration of particulate matter 10, that means the particulate matters with the diameter of 10 micron and less, so that it can detect. And this type of thing we will study in this particular lesson, right. At the end of the lesson, the viewer will know the principal pollutants in the atmosphere, then the detection and measurement techniques. What are the different detection measurement? Please note that in all the cases, most of the cases, the detection techniques based on the optical system. So there is some filter, so we will take out the output and measure it. So basically it's an optical method of measurements in all the cases of the gas detections. Then we have gas detection based on optical filter, as I told you earlier. Then we have color code of air quality index. We have a color code, so that looking at the color, I can say that what is the quality index of the air or the environment, right. So this all the things we will study in this particular lesson. introduction, let us see. The sources of pollutions are many and varied, as I told you, and include factories, automobiles, burning dumps, power generating station, household furnaces, and so on and so forth. Right? These are the different types of pollutions you will get. There are many other pollutions you will find that these are basic municipal pollutions which you will have. The factories, automobiles is the most main source of pollutions in any big cities or metropolis. Okay. Power generating stations, even though sometimes it is remote from the area from the main cities, but you will find that will pollute the neighboring areas, neighboring villages. Okay. Then it destroys the nearby paddy fields, all those things are there. And household furnaces, though it is not very common in our country, but you know that many places still the people uses the coal based stove, that coal based or kerosene, but that is also pollute the environment. So, we will study all these things. Now, common harmful chemicals that are emitted into the atmosphere include hydrocarbons, oxides of nitrogen, which is called Nox or NOx, nitrogen dioxide, nitrogen monoxide, carbon monoxide, and sulphur dioxide. These are the main basic pollutions which we will get in the which are harmful. Now, 10 to 17 milligram per meter cube of carbon monoxide is common on a busy streets, and more than 120 milligram per meter cube is considered dangerous. So, if it is, that's I told you, we cannot we cannot say that any environments will be totally pollution free. So, when you live in a city, so we have to live in a city, large number of people live in a city. So, there will be some pollution, but if it is within the safe limit, that is fine, no problem. But if it is crosses that particular limit, which is hazardous. The various ill effects of these pollutants on the human health and the environments are well known, right. So, there are various types of, there are causes of bronchitis, asthma, all this pollution make the people sick. So, that this content should be less and less. It is now recognized that many chemicals undergo photochemical decompositions and reactions in the atmosphere, forming different pollutants which may be even more toxic than their precursors. So, this is another problem, because you see it will react. So, it is a photochemical decomposition. So, it will make some other pollutants which is more dangerous. The nitrogen oxides and hydrocarbons are the most important source of secondary pollutants. Smog is it's called a smog and fog. So, in many cities you will find in the morning this full of smog. That means visibility is extremely poor. So, it is very difficult for the persons to drive in the streets, or very difficult for the aircraft to land, very difficult for the train to move. So, due to this smog. So, this is also very important sort of pollutions. Analytical chemistry and photospectrometry plays a very important role in measurements of environmental pollution. So, these are the most important things we are usually measuring. This type of, as I told you, is basically spectrometry plays an important role in measurements of pollutions, or quantify the pollutions. We are talking of just in qualitatively, but we must quantify it. Otherwise, how will I know whether it is 10 to 17 milligram per meter cube, whether it is it does not cross or did not cross the 120 milligram per meter cube. The complete process can be broadly split up into two steps: sample collections and sample analysis. So, obviously, we will first collect the sample of the air which I want to analyze, which I want to know how much the pollution there, then the sample analysis. Sample collection. One of the most important steps in air analysis is the collection of the sample. Okay. Once the sample has been collected, standard measurement techniques may be employed. The topic of sample collection can be broken down into two broad categories: general considerations and sampling train. Okay. So, what is the different precautions we will take for sampling collections? Okay. What is the velocity of making the suction from the environment, and all these things. General considerations. The following are the points which must be kept in the mind before going for sample collection. Size of the sample. The volume of the size means I am not talking of the size of the dust particles, or the size of the sample, how much air you will collect from the environment to analyze it, right. That is I am talking of the size of the sample. The volume of air sample is governed by the minimum pollutant concentration that must be measured. The sensitivity of the measurements and the information desired. The sample size is generally chosen by trial and error method, and trial samples of more than 10 meter cube may be required to determine ambient concentration. Sometimes we need large volume to know the ambient concentration or an average concentrations, okay, instead of taking very small, but we may need very small, but we take a large, then obviously the results will be on average, we can average over a particular area. Rate of sampling. The useful sampling rate will vary with the sampling devices and should be determined experimentally, okay, so that you have to determine experimentally. The most sampling devices for gaseous constituents have permissible flow rate. As I told you, we have to collect it with some suction pump, also that type of thing. So, velocity will be 0.003 to 0.03 meter cube per minute. Okay. Now, duration of sampling, that is also important. Time of the day and the duration of sampling will be determined by the information that is desired. Okay. Because the time, because if you go to busy streets, if you take a sample at the 5 o'clock in the morning, there is no use, hardly that time any pollutions, but at the 10 o'clock in the morning, if you take something, you will get the estimate, you will get the exact how much the pollution is there, or what is the worst case pollutions in the streets in the evening or in the morning. Sampling period will give the indications of only the average concentration during that period. So, suppose I am taking for 1 hour, so that means I am collecting over averaging over 1 hour. So, that is a good measurement. Then storage time of sample storage, this is so important. Storage time of the air sample should be kept to a minimum. Okay, it should be, because in some cases it can be decomposed, so that it should be after making the collection we should make the quick analysis. They should be protected from heat and light, this is another important thing. Care should be taken that the desired test component does not react with the other constituents or with the container. So, the container should be sort of inert, but probably made of glass or stainless steel, so that it will not, whatever the pollutions or the the gases that should not react with the container, okay, those things should be considered. Gaseous samples are sometimes collected by the adsorptions onto a solid, and the gases must not be lost by desorption prior to analysis. Okay. Many samples collected by adsorption, that means it will be on the solid material and it should not be released, or desorption prior to the analysis. Okay. So, because if you do that, if it dissolve before the analysis, obviously that particular gas will be lost, we cannot be analyzed, even though it will showing there is no that type of gas is there, but actually it was there, by that time it is lost. Sampling train. The requirement for intermittent air sampling are a vacuum source, a means of measuring the amount of air sampled, and a collector. Okay. So, we have a vacuum source, so that, and a means of measuring the amount of air sampled and a collector, because if there is no vacuum source, that we cannot collect the sample, right. Vacuum source, whatever vacuum source, motor or hand driven vacuum pumps, aspirators and automobile vacuums are generally used to draw the sample through a collection devices. Clear? So, this is basically a pump by which you will collect the sample from the environment and stored in a collector. When vacuum devices are being used to draw the sample through a filter in which the pressure loss may build up during the sampling, it is recommended that some constant flow devices to be attached to it. Right, some constant flow devices should be there, so that because if I use a filter, so obviously there will be some pressure loss across that filter. Now, metering devices. Flow measurement devices are of two general types. We have seen this, we have studied these flow measurement devices in this particular course of industrial instrumentation. The some will make, as you know, some will make the rate measurements, some will make the volumetric flow measurements, some will make the mass flow measurements. We are more interested here, instead of the rate measurements, on the volumetric measurements, right. Flow measurement devices are of two general types, those measure the rate and those measure the volume, okay, or you can make the total volume also. These devices, the devices that measure the flow rates are small and inexpensive, but have the disadvantage of measuring only instantaneous rate of flow. One is rotameter. Rotameter is just will make the instantaneous rate of flow, okay, it will not make the total volumetric flow of a devices over a certain amount of time. Devices that measures the volume record that flow passing through them and are therefore more useful. They are, however, bulkier and more expensive. Okay, rotameter is very simple devices, as you know, it is a very indicating sort of instruments. We have studied this in details in the flow meters, but other devices where we can suppose a flow meters, like a turbine flow meters and all these things, or any other gas flow meters, we can measure this one, like orifice meter also will be, because that is bulkier obviously. All gas measuring devices should be calibrated before use, because you are measuring the volume, so how much collections we are taking, so it should be calibrated before. A direct calibrations with the actual gas can be carried out by means of gasometer system. Here the gas flowing to the flow meter during a timed interval is trapped in the gasometer bell and its volume is measured. Okay, a gasometer bell is there and the volume is measured. Okay. Collector. The last component of the sampling train is a collector, which may be a variety of types depending on the particular applications, right. So, these are the very important things, so for consideration. Okay, basically if you look at the gasometer, basic principle is something like that. This gasometer is basic principle is that it has a known volume of device. Direct calibrations with the actual gas can be carried out means the gasometer system, where the gas flowing to the flow meter is trapped in the gasometer bell and its volume is measured, right. It is like this one, it is a, if I look at it will like this one is a, if I take a new page and new color, so it is a bell sort of thing over this one, okay, and water is there, so that it is trapped and going like this. So, the bell will come down, this water level comes, so gas will be trapped here in this, so that the volume will be known to us. Okay, so it is as simple as that. This is called basically gasometer. Collector. The last component of the sampling train is the collector, which may be a variety of types depending on the particular applications. Aerosol contaminants. One of the most commonly used means of collecting aerosol contamination is the filtrations. Okay. Fiber filter, wood fiber, paper, glass fiber, asbestos, these are granular filter, glass or metal or porous ceramic sand, and membrane filters are used. Okay. Cellulose, ester, so these are the different types of filters which are used commonly of aerosol contaminants in the filtrations. A second type of collection device for both the solid and liquid aerosols contaminants is the impinger, right. The aerosol impinge on a surface exposed to the air stream, and those contain both dry and wet impingers. More sophisticated collectors include electrostatic precipitates. Precipitates, you know that that is the one sort of collection devices, that's in other sense it is reduce the environment pollutions, where using in the power plant these are mostly commonly used, because there is a pollution of the ashes. So, that if they use electrostatic precipitators, so that will collect that ashes, and we can that will not go to the environment. So, okay, that type of principles are used here. Okay. Now, gaseous contaminants. Gases and vapors may be collected by the absorptions in a liquid, adsorptions on a solid surface, freezing or condensation, or filling and evacuated containers. Okay. Evacuated containers also will do, as I told you, we have told earlier, or it can be by the freezing, or can be condensation, or can be by the absorptions. So, in a liquid or adsorptions on a solid. So, these are different types of method by which I can make the collections of the contaminants, right, gaseous contaminants. Absorption is one of the most widely used techniques for gases collection. The gas components of the interest are dissolved in a suitable liquid or solution, or on the surface of the hygroscopic solid. The most efficient absorption device is a fritted glass scrubbers, where it can be collected. Okay. Carbon monoxide detections. Carbon monoxide concentrations are measured by a technique known as non-dispersive infrared spectroscopy. Okay, it is called the non-dispersive infrared spectroscopy. The vast majority of the covalently bonded molecules absorb infrared radiations somewhere in the wavelength range of 3 to 15 micron, right. Somewhere in the range of 3 to 15 micron it absorbs, and this is the entire range of your absorption spectra for various gases in the infrared region you see here. you see here. Okay. So, these are IR. Okay, this is a range of, you see, these are the range of our, where you can carbon dioxide, then carbon monoxide, then methane, C2H4, all these things. These are the wavelengths of lights, and what is the absorption spectra for the various gases in the infrared regions we have shown here. Clear? This represents the amount of energy required to start atoms vibrating with respect to each other, right. And carbon monoxide is a very simple molecule that has only one mode of vibration analogous to that of a coil spring, like this one. Okay, like a coil spring, wounded coil spring, it will have a vibration like this one, right. So, what it will do, it will go to the displaced positions, okay, and it will come to the same bond again. So, releasing the energy, light energy, right. We will show that analogous to. The carbon monoxide absorbs infrared radiations at wavelengths of around 4.67 micron. Okay, that is the wavelength. It will absorb the infrared radiations. The atoms take up the light energy to move slightly further apart from the normal. Okay, as I told you, it is going further away. There are two atoms are going further away. Atoms light energy to move the start further away. Then it collapses and releasing the light, going to the same state again. So, the atoms take up the light energy to move slightly further apart than the normal, and then liberate that energy in the form of a heat when they decompress. Carbon monoxide detectors can be split into two types. The method depends on the measurements of energy or heat liberated after IR rays have passed through the sample. Okay, after the heat, after IR rays pass through the sample. So, that is one method. Next method is, that means the, as I told you, that means I have atoms, it will be delete, we will show you. The method depends on the electrochemical analysis. These are the two methods. One is the total, optical method, and the electrochemical method, right. Now, detectors based on the heat absorptions, that means it looks like, you see the, what will happen, that means it will have like this one. So, I have here So, we have like this one. So, after light energy it is bonds like this one. So, it is going on like this one, excited after when the if it is infrared passed. So, this will be liberate the light energy, that will be detected, right. That is the basic principle. Carbon monoxide analyzers pass an infrared light beam alternatively through a reference cell containing a non-absorbing gas like N2, nitrogen, and a sample cell containing air with carbon monoxide to be measured. The infrared light of 4.67 micron wavelength is absorbed from the sample to the extent that corresponds to the carbon monoxide concentration, right. The next step is to receive the infrared beam through a nitrogen filled reference cell and a sample cell, which now have a different intensities due to light absorptions by carbon monoxide in the sample cell, then nitrogen filled reference cells, right. So, this is the thing. The difference in the measured intensity is converted to a carbon monoxide concentration, right. So, these two difference, one will be without carbon monoxide and this with carbon monoxide. So, we get a difference. Now, detectors based on the electrochemical analysis looks like this. When the gas is electrolyzed while maintaining the potential between the electrodes immersed in electrolyte, the current assumes value proportional to the gas concentration, right. The gas is electrolyzed, maintaining the potential between the electrodes immersed in the electrolyte, and the current assumes the value proportional to the gas concentration. Why? You see, because the electric potential at which the electrolysis takes place, okay, depends on the gas only, carbon monoxide concentration, and the carbon monoxide concentration is measured. Now, carbon monoxide concentration is therefore obtained from the potential. So, if I measure the potential, that potential can be calibrated in terms of the carbon monoxide concentrations in the gas, because electric potential at which the electrolysis takes place depends on the gas only. Okay. So, depends on the concentrations of the carbon. So, if that voltage is calibrated in terms of, you can directly calibrate that voltage in terms of carbon monoxide concentration. Now, Nox measurements, it is a very common not only in our environment, but also in industry. Okay, NOx, that means nitrogen oxide and nitrogen dioxide. These two types of pollutions, I mean gas, we are calling it the Nox. Okay, Nox Analyzer, Nox Measurement, Nox gas. So whenever we are talking about, we are I mean of this Nox means NOx, it means NO subscript X, it means that the nitrogen oxide and nitrogen dioxide. When nitrogen monoxide, or sorry, I am not, instead of nitrogen oxide, nitrogen, both are nitrogen oxide. So, NO is the nitrogen monoxide and nitrogen dioxide is NO2. When nitrogen monoxides or nitrogen dioxides in the sample reacts with ozone, which is produced by passing externally supplied O2 over UV lamp, part of the NO is oxidized to become a nitrogen dioxide, right. Part of NO2 generated in this is in the excited state. Excited state, so actually we are defining it by this one, please note. This phenomena is called the chemiluminescence. Actually you see here, so we are defining this NO2, this asterisk means it is in excited state, I am sorry, it is in excited state. NO2 asterisk, if it is excited state plus O2, so it is NO2 excited state, it is liberating the, actually this will be H nu, I am sorry. This will be H nu, NO2, second equation, if you see NO2 asterisk, which goes to NO2 plus H nu, right. We can, this will be if I, this will be H nu, right. So, the light will be emitted. So, above mentioned reaction is very fast and only NO is involved without almost any effect of the other coexistent gases. So, this also you should remember, because it should not react with other gases, so the other concentration of other gases cannot be detected by that type of method. So, the phenomena is called the chemiluminescence. So, by this, so it is the nitrogen oxides react with ozone, it is making nitrogen dioxides, which is in excited state, it will go back to the normal nitrogen dioxide state or nitrogen dioxides liberating light, right. So, this method is very fast and only NO is involved and without almost any effect on the other coexistence gases. If the NO is at a low concentration, the quantity of luminescence is in the proportional to that concentration. The nitrogen monoxide is a low concentration, the quantity of the luminescence is in the proportions of that to that concentration. Now, NOx analyzers separate the sample gas into the two portions. In one portion, nitrogen dioxide is reduced to NO by the NOx converter and used as a sample gas for the measurement of NOx, which is NO plus NO2, nitrogen oxide and nitrogen monoxide, nitrogen dioxide. In the other, the NO sample gas is used as it is. These sample gases are switched to the NOx, NO and reference gas lines by the solenoid valves every 0.5 seconds and are in turn introduced in the reaction chamber. On the other hand, the open air that was separately sucked through the air filter is dried by the self-reproducing type silica gel dryer, then introduced as ozone gas into the reaction chamber by the ozonizer. On the other hand, the open air that was separately sucked through the air filter is dried by the self-reproducing type silica gel dryer and then introduced as ozone gas into the reaction chamber by the ozonizer. In the reaction chamber, the sample reacts with ozone. The light emission involved in the reaction is detected by the photodiode. Okay. So, whatever the light detection is coming out is detected by the photodiode. It is in turn gives a current that is calibrated as a concentration. So, photodiode output can be photodiode output will be current. Okay. So, that can be, the photodiodes always can be used for detection of the lights. So, that can be calibrated in terms of concentration. Now, what is the precursors and pre-processing of this, that we must note? One of the problem with Nox measurement is its affinity to water. Okay. So, any water, so immediately it will be absorbed and you cannot find the Nox. So, that the container should be totally air or water free, that is most important thing. For this reason, it is important to remove the practically all the water from the sample, okay, because when it is in the sample, so it may have other so that when before analyzing, so this from the sample, before analyzing the sample, all the water should be removed. Dryer is used for this purpose because silica gel dryers and all these dryers, obviously it will remove the moisture contents in the NOx, keeping the NOx as it is for the analysis purposes, because ultimately we have to make the analysis of this NOx. Now, sulphur dioxide is another form of pollutions in the environment, so we must look at what is this type of pollution this is. Is a very hazardous, okay, so we must know the contents of the sulphur dioxides in the air. Analysis of sulphur dioxide is based on the principles of fluorescence spectroscopy. As I told you, mostly this basically depends on the spectroscopy. So, this is also fluorescence spectroscopy. Sulphur dioxide has a strong ultraviolet absorptions to a wavelength between 200 nanometer to 240 nanometers. Okay, within that it has strong ultraviolet absorptions. The absorptions of photons at this wavelength results in the emissions of fluorescence, because where this energy will go, it cannot just get lost. So, that this energy will consumed in the sulphur dioxide atom and it will release the fluorescence, right. We will measure the fluorescence and calibrate the by spectroscopy and calibrate that in terms of the sulphur dioxide concentration. A zinc discharge lamp and a bandpass filter, optical bandpass filter obviously, radiates ultraviolet light at 215 nanometer into the reaction chamber, where it interacts with the sulphur dioxide molecules, right. The fluorescence is measured perpendicularly to the beam using a photomultiplier tube. Photomultiplier tube is nothing but is a series of instead of nowadays instead of photomultiplier tube you can use a photodiodes also or phototransistors. So, photomultiplier tube is just it multiplies it increases the output current, as simple as that, nothing more. Okay, you must learn it increases the current at the output. The amount of fluorescence is directly proportional to the concentration of sulphur dioxide, so, okay, which we are measuring with the photomultiplier tube. One of the major problems with the sulphur dioxide is extremely corrosive nature and affinity to water, same as the sulphur dioxide, as I told you, but sulphur dioxide is nitrogen NOx is not that corrosive, but the sulphur dioxide is a corrosive in nature as well as it is affinity to water. So, both you have to take it is more we should take higher precautions for analyzing the sulphur dioxide than nitrogen. Nitrogen dioxide, if I remove all the water, that is fine. So, there is by some dryer or some other means, no problem, but here that we have to think that whatever the containers we will take, that should not react with the sulphur dioxide. The presence of any condensate will quickly remove all traces of sulphur dioxide from measuring system. So, all this, if there is a little of presence of any water, obviously it will remove all the traces. Okay. So, ultimately while you are analyzing, you won't get any SO2, giving you a wrong measurements or wrong indication, that is undesirable. In addition, there is an absorptions line for water very near line for the SO2. This is another problem. This means that the presence of any water vapor will affect the low readings of sulphur dioxides to be expected. There is another problem. So, not only the reaction, but this line also lies very close, so that there will be low readings of sulphur dioxide in presence of the water, right, water vapor or water or steam, whatever you call. Infrared sensors for sulphur dioxide has the advantage of lower cost, but at the expense of greater size. Infrared sensors are there, but it has a advantage of the lower cost, but obviously the sizes will be quite big in this case. Nevertheless, infrared source sensors are one of the most preferred methods of measuring SO2 concentrations in the field nowadays, right, because of those advantages of this. That line corresponds to very close to the line of the water vapor. Now, ozone detections, you see how you detect the ozone. Ozone detector works in the principle of absorption spectroscopy or spectrometry or photometry, right. The wavelength range for ozone is 220 to 330 nanometer, and the absorption spectrum is extended to 253.7 nanometer, which corresponds to the main emission line of mercury. So, the ozone absorption coefficient was experimentally defined at 253.7 nanometer. To determine ozone concentrations, a sample of ambient air is drawn through a flow cell, which is irradiated with ultraviolet light of wavelength 253.7 nanometer from a mercury paper lamp. Mercury paper lamp will make an particular wavelength. Okay, this 253.7, as I told you, its line is same as the mercury. So, it will produce that particular wavelength, stable wavelength. The intensity of ultraviolet light detected by the instrument is reduced depending on how much ozone is in the sample to absorb it. Okay, if there is more ozone, so obviously it will absorb more, so the intensity will be reduced. So, that is why I say the intensity of ultraviolet light detected by the instrument is reduced depending on how much ozone is in the sample to absorb it. If the more less ozone, so I will get more better higher output. If the more ozone, I will get less output. So, that is an indications of the concentration. A second source that has been scrubbed off ozone using a manganese dioxide, okay, scrubber, is then drawn through the absorption chamber, resulting in a higher intensity of light reaching the detector. Clear? The difference in the intensity of the two yields the concentrations, yields the concentrations of the ozone in the sample. Okay, difference of these two intensity will give us the sample. Now, measurements of hydrocarbons, as I told you, hydrocarbons means combinations of this methane, ethane, all these things are basically we are calling hydrocarbons. In petrochemical industry, sometimes we call it hydrocarbon inverse industry also. The flame ionization detector is the most commonly used detector for the analysis of organic compounds or hydrocarbons in the both in the environment as well as in the factory. Its sensitivity, linearity and user friendliness make it the ideal detector for measurements of hydrocarbons. The ionization mechanism of organic substances in the flame is carried out in two phases. Okay. What are the two phases? Let us look at the cracking of organic compounds in the center zone of the flame and forming the CH2 CH3 radicals. Okay. CH radicals, CH2 radicals and CH3 radicals. Okay. By cracking these organic compounds, the center zone of the flame and forming of this type of thing, this type of radicals. Chemical ionization in contact with the oxygen according to the reaction CH radical plus O, which will give you CHO plus electron, 1 electron. The molar response is defined as being the proportional to the number of atoms of the carbon of the molecule. The electrons are extracted from the flame using a voltage polarization applied between the nozzle and the collecting electrode. Okay, between the nozzle and collecting electrode, it will be. Now, this is a figure of general functional diagram of our. You see the polarizations. We have a collecting electrode, we have flame here, then we have a 0 here. The sample is injected through E1, and this electrometer. I am sorry. The electrometer signal is nothing but a high input impedance meter, voltage meter. So, it will collect the signals like this, right. Current obtained from the collecting electrode is converted to a voltage and subsequently it is digitized by the ADC for further processing, right. Because if it is analog signals, I have to convert to the digital domain by ADC. Figure 2 shows the detailed mechanisms which I have just shown, the detailed mechanism of this type of detector. The flame ionization detector sends a signal proportional to the number of atoms composing the hydrocarbon molecules present in the sample or total hydrocarbons, right. Now, another important thing is the air quality index. Okay, what is the quality? How do you index? How do you, make the air safe and all this thing? You must have some index, because if you look at the general, public, they will not understand what is this concentration or what is a safe thing. So, let us better it is expressed what is the concentration of carbon monoxide in the air, what is the concentration of sulphur dioxide. Instead of that, we make the air quality index, which includes the visibility, also the quality of the air. So, this air quality index. Now, let us look at meaning and use. The air quality index is an index or rating scale for reporting daily the ambient air pollution recorded in the monitoring sites. Okay. So, it will usually records, or it will give some index, okay, how the air quality in a particular site is good or bad, right. So that's why I'm saying air quality index is an index or rating scale for reporting daily the ambient air pollution recorded in the monitoring sites. The two objectives of AQI are to inform and warn the public about the risk of exposure to daily pollution levels, as I told you earlier. So usually we will define this thing. Obviously, we must have a goal that we have to reduce this to some level. Okay, so people also will know. So there should be some protective measure to come down, to bring it down to a particular level. To enforce regulatory measures for moving AQI, improving AQI, so that what is the precautions we should take, what type of, you know that you say that recently we have the air quality is very extremely poor in India, in the and a metropolis like Delhi, because there is a lot of automobile pollution there. So they have converted to everything to CNG, so which will give you less pollutions. So this type of, so they every time they will measure the what is the quality of the air people are inhaling, okay, what is the dangerous level, and once they have switched to CNG, all the cars, all the buses, people found the air quality index improved a lot. Okay, so this will give you some measure, or the viewer with a single index, people will know the how my water, how the environments of the air which I am inhaling good or how good it is. The AQI or air quality informs the public about the quality of the air and associated health effects resulting from inhaling polluted air. Okay, what is the ill effects and how can you reduce, and all these things to be discussed. The higher the AQI value, greater is the level of air pollution. So, okay, obviously the higher the value, always desired value should be lower and lower. So that is most important thing for air pollution. 4 major pollutants including the suspended particulate matter is PM10 are considered for reporting AQI. PM10 is a particulate matter of 10 micron, of size 10 micron or less. There are PM 2.5 also, but we are considering a PM10, that means not more than that, right. So we are considering the PM10 particulate matter of size 10 micron. Measurements and calculations. The concentrations of the pollutant is measured by air quality monitoring equipment at a monitoring station. This pollutant concentration is converted to an index value using the following equations. Index value, pollutant concentration, pollutant goal concentration into 100. Okay, what is our goal? Okay, what is actually desired value of the concentration, and what is the actual concentration now? So that will give you the index value multiplied by 100. Okay, that is give you some quantitative measure for the quality of air people are breathing. The pollutant goal concentration used to calculate the index value is either the AR NEPM standard for that particular pollutants, or the EPP goal in the case of visibility. Let us look at what is NPPM and EPP. NPPM is the NEPM is a national environment. I should take a different colors. I think these are not very good colors. NEPM is the national environment protection measures. Every country has this thing. Okay, so this is national protection environment protection measures is a basically our broad framework setting statutory instrument defined in the National Environment Protection Council, and they outlined and agreed national objectives for protecting or managing particular aspects of the environment. This is basically NEPM. Okay, and also we have EPP. You see there that EPP is basically environmental protection policy, environment protection policy. So this also will look at all these things. Now, so these are the now see this PM10, that's also we were talking about the PM10. Let us take a new page. PM10 is the particulate matter of includes particles with a diameter, includes particles with diameter ten micrometer, which is coming as 0.004 inches, or I should say, or 1/7 width of human hair, right. We have then PM 2.5, that's we are not discussing. Okay. Previously it has a TSP monitors, that's also we are not discussing here. Okay. The pollutant goal concentration used to calculate the index value is either the AR NEPM standard for that particular pollutant, or the EPP AR goal in the case of visibility. Visibility is most important because you see that if the AR, if there is suspended particles, or if there is the PM10 is there, so obviously it will reduce the visibility of a person. So what is the goal? What should be the visibility? Whether it is a 10 kilometers or 20 kilometers, that we must know. So this also will give you some standard, okay, for particular country. So let us look at that. The AR NEPM standards and EPP AR goal used to in calculating the index values are presented in table 1. You see here, that's AR NEPM standards, that ozone, it is 0.10 parts per million. So we have taken the average time of 1 hour. Nitrogen dioxide 0.12 parts per million, that is 1 hour. Sulphur dioxide 0.20 parts per million, and for 1 hour. Carbon monoxide we have taken for 8 hours, and PM10 we have taken, it's 50 microgram per meter cube for 24 hours. Okay, these are standards or NEPM standards. And pollutant and the visibility is 20 kilometers. Okay, so EPP is that, yeah, that is our goal, is 20 kilometers, right, for 1 hours the averaging time. The EPP AR goal for visibility reduction particles is 20 kilometer visibility, which means you would be able to see the clearly for at least 20 kilometers. Obviously this is the sort of pollution, because some pollution we should, why we have taken the PM10, you see that these two are should be different, because some gases are this carbon monoxide, these are not visible, ozone is not visible, that will pollute the air. Okay, the two types we are considering, one is the visibility consideration and the health hazard, just health hazard. Okay, because visibility is also making the it's not hazardous to the people or the persons or the public, but it's make the our other things difficult. That means the landing of the aircraft or taking off or moving of the train or moving of the cars, everything becomes difficult. That's also measurements of the pollution. That is the reason we have PM10 we have introduced. This goal is related to the light scattering coefficient value measured using an effluometer. A scattering of 235 or less is equivalent, where mm minus 1 is the per million meters is equivalent. So, a scattering of 235 millions per million meters or less is equivalent to visibility of more than 20 kilometers. Okay, so, this is also will give you that what is the visibility. Usually in many countries nowadays they will straight away will give you the visibility. Okay, so, that from that measurements they can see the visibility. Meaning or interpretation of AQI reading: the higher the AQI value, the greater is the level of air pollution and greater is the danger to health. Okay. Not PM10 is also there, but that is also considers with the visibility. AQI for suspended particles is 305 and is the highest out of the 5 pollutants, and it is reported as an AQI of 305, right, air quality index of 305. AQI indicates the maximum safe levels for a pollutants, and above this level the pollutant has undesirable impact on the people and the environment. Okay. So, this will give you some indicates the maximum safe levels for the pollutants, how much pollutions it can cause. So, if it goes above that level, so it is not good for the health of the persons or the any animal being. If AQI falls below 50, or the air quality is considered extremely good. Okay. If it is called, obviously as I told you, if the AQI is higher, pollution is more. An AQI reading between 51 to 100 indicates that the moderate air quality. An AQI reading from 101 to I think this should be 200. Sorry, this will be should be 200. Okay. So, if AQI falls below 50 at the air quality is considered good, and AQI reading between 51 to 100 indicates moderate and air quality, and AQI reading from 101 to 200 indicates the poor air quality, and reading over 201 indicates the very poor air quality, and AQI of above 301 is regarded as a critical to human health. Okay. This is some category. It depends, it varies from country to country, but this is the obviously always will desire that it is desirable that the AQI should be below 50, right. Now, you see we have then, now this is a color code of representations of AQI. We have given the color code representations. Okay, that is anybody can understand that. The green means always friendly, as you know the environment, green environments we are talking about always is a good environment. So, we have given a color of green. So, 0 to 5 I mean AQI value, so it is green color, it is good. 51 to 100 marginal moderate, we have yellow. Yellow, well, I cannot justify why it is yellow, it is some standard is to be followed. Obviously, the green means that our environment is green, always is better for us. Then we have 101 to 200 unhealthy, poor, I mean orange. Then we have a 201 to 300 AQI value, very unhealthy, very poor, which is considered red, alert. Red means always alert, and 301 plus is a critical. I mean, there is no more for consumptions of the. I mean, for that year is consumption for the human being or any living animals. So, these are the things which we have considered in this. What we mean to by AQI. So, because if you give the color, because it is very difficult to remember all these numbers. So, instead of giving the numbers, we will measure this one, but once we define when to the public. So, we will give with some color, so that green is better, yellow is okay, fine, orange is not that good, red is quite bad, and if the purple it is extremely bad, right. So, with this AQI color codings we can explain to the general public. So, what the color they should have in their particular area of residence or a particular area where they are working. So, with this I come to the end the lesson 37 of industrial instrumentation. Welcome to the lesson 38 of industrial instrumentation. In this lesson we will cover the control valve. In fact, this lesson 38 and 39 both will be dedicated to the control valve 1 and control valve 2. Control valve, as you know, it is a final control element in a process, and it is most important part of any industrial instrumentation. Now, so far we have studied, as you know, the many sensors which actually measure the process variable flow, temperature, pressure, viscosity, pH, or so on and so forth. Now, all this actual measurement is to basically to control some that particular process. Suppose in the case of temperatures or in the case of flow, we have to control the temperature. We have a set point. So, our goal is to to make that whatever the set points determined by or fixed by the engineers, our system should attain that particular value, right. So, some or the other we need control valve. Now, control valve is basically is a device which will resist the flow of the fluid, either liquid or gases, through a pipe, right. This is the basic purpose, and directly it is controlling the flow, indirectly it is controlling the temperatures and any other process parameters, right. Suppose I have a indirect heating of a boiler. So, we are heating it by a superheated steam. In that case, by controlling the amount of steam also we can raise the temperature of the boiler, and directly in the case of flow measurement there is no problem. I mean, these are the only factors which is to be included, which I have to think of, otherwise not. The general form of the sizing equations for the compressible fluid is, you see, CV equal to Q upon N FP P1 Y root over X upon G T1 into Z, equation number 19, where the legends are X is the ratio of the pressure drop to upstream absolute static pressure, okay, ratio of the pressure drop to upstream absolute static pressure. That is the reason we are interested in P1. The previous equation number 18 also we have seen that there is a P1 is important, not the P2. Y is the expansion factor ratio of the flow coefficient for a gas to that for a liquid at the same Reynolds number. Z is the compressibility factor, and T1 is the upstream fluid temperature in Kelvin. Okay. So, all these things, all the legends are defined. Now, every time you see that a CV is the most important thing in the valve parameters, there is no other, because if you define CV or if you find CV, all other parameters will be automatically fixed. There are some parameters like small d, capital D. So, first in the while you are choosing the valve, first I have to calculate the what is the desired CV you want for a particular applications. Once you find the CV, so from the selected list of the valve, so you try to choose CV which will match very close. You may not get the exact match, if it is 70 to 90% of the value of the CV which you have seen, that will be the desired range of the control valve. Okay. So, that particular control valve is to be chosen and is to be installed in the process. Now, with this we will cover this in industry, I mean this control valve, we will continue this control valve in the lesson number 39 also. We will go further details and we will solve some problems in the lesson 39. So, at this with this I come to the end of the lesson 38 of industrial instrumentation.